On this program, a trip down the information superhighway. A leap into space to meet up with a satellite. And a well-earned moment's relaxation in front of a television that satisfies our every whim. Copper wires, optic fibers, coaxial cables, radio relay systems, and satellites form an endless highway, the information superhighway. Images, sounds, texts, and data whiz down it from one end of the world to the other at tremendous speed. Telecommunications have obliterated distances. They bring us all together in the same time-space. Carol is a biologist. Although she's working at home in Montreal, she is in communication with a colleague stationed in Dakar. He is sending her his latest findings on the Anopheles mosquito, the insect that transmits malaria. Their video conference is relayed by satellite and by landline telephone networks through a video modem plugged into each of their computers. So not only is Carol able to receive computerized data and hear her caller, but since each of the computers is equipped with a camera, she can also see his face in a corner of her screen. In another room, Benoit, her companion, is programming a digital video terminal to regulate the temperature and lighting in the house, according to the family's schedules. That terminal is therefore linked to the house's electrical system. It is also linked to a coaxial cable, which provides access to several television channels and data banks. It allows, for example, such activities as banking and teleshopping from home. Their son uses this system to improve his French with an interactive game that helps him practice his grammar. While not all of these technologies have been implemented yet, many already exist. Others are still under study, but will be available in a few years. Researchers are even looking into ways to create a virtual classroom in which teachers and students would take part from their respective homes. Each using a computer, they would communicate by telematics and interactive multimedia. The student would be able to talk to his teacher or carry out a team project with other students without even having to leave home. In large corporations, education from a distance could be used to train employees, especially since some organizations already have their own communications network. In fact, the ability to translate data into digital binary codes has spawned a multitude of information vehicles. Today, the fabric of the planet is woven with a highly intricate telecommunications network. Under every latitude, at every longitude, and altitude, there is at least one telecommunications system available. Whether by copper wire, fiber optic, coaxial cable, or satellite, video images, sound, and computerized data can now be sent anywhere in the world. It is the age of multimedia. The key element in the transmission of numeric data is the optic fiber. It is a glass wire whose diameter can be 100 times smaller than hair. Exceptionally pure, it is the most perfect transmitter of information ever invented. It transmits binary information in the form of light impulses. Theoretically, just one of these fibers could carry all the telephone and program signals of the entire United States. Most common communications carriers use fiber optic systems to transmit their signals from one ground-based point to another. When their networks get close to communities, The copper wire and coaxial cable take over to carry the signals into the homes. There are some drawbacks to this, as neither system is able to receive the vast quantity of information carried by fiber optic. The problem is solved by data compression. It applies more specifically to video images, such as film or television programs, because they take up more space. They are compressed by removing redundant data from the video signal. Also, advanced modulation techniques have made it possible to boost over short distances the information carrying capability of the copper wire used in telephone lines. For such distances, copper wire is sufficient to relay the digital data of video images from the optic fibers to a user's television set or computer screen. The images come through just as clear as a video recorder's. Thanks to developments in the area of virtual reality and robotic vision, perhaps it will someday be possible for someone in Paris to visit an exhibition in Montreal without even stepping out of his door. Indeed, it will be possible to record an entire exhibition hall in 3 dimensions by scanning it with a laser beam. The data collected could then be digitized and broadcast throughout the world via satellite. The 3D images would be viewed with a virtual helmet. The day is not far off when an information superhighway will cover every square foot of the planet. Still, we will always have the option of simply pulling the plug. In the early 60s, telegraph and telephone cables no longer satisfied demand. They wouldn't enable us to go any further in our attempts to create a worldwide communications network. Satellites picked up the slack. Satellites are not only used to transmit video messages, but computer and telephone messages as well. And in some instances, communications satellites are needed to reach remote areas that are hard to serve by traditional networks. When 2 persons geographically far away from each other want to communicate, 2 satellites sometimes have to be used. In such cases, the traditional networks such as cable, fiber optic, or copper wire are not enough. Let's follow, for example, the routing of a telephone call to China from eastern Canada. The call is first relayed via a ground-based network to a sending antenna that transmits the message to a satellite located above the Atlantic Ocean. That satellite sends the message to another ground station, this one in Italy. From here, the signal is transmitted to a second satellite, this one situated over the Indian Ocean. The call is then retransmitted by that satellite to an antenna in China. From there, the voice is relayed to the Chinese caller. This procedure is called a double hop. The double hop, however, causes a delay between the transmission and the reception. That delay, which can be up to 2 seconds long, makes for a rather unpleasant conversation. The double hop is therefore only used as a last resort or for very specific purposes, such as espionage, where it is important to conceal the source of the call. Geostationary satellites are the ones most widely used. Such satellites are termed geostationary because they revolve around the Earth at a speed that maintains them stationary over one point of the Earth's surface. They orbit at an altitude of 36,000 kilometers above the Earth. They are able to maintain their geostationary orbit due to the speed at which they travel and the distance that separates them from Earth. Indeed, when an object moves in a circular motion, It tends to shift away from the center of its orbit due to centrifugal force. This is what happens with satellites. At the same time, they are subject to the Earth's attraction, or the force of gravity. At 36,000 kilometers of altitude, these two forces are equal. Moreover, the satellite orbits the planet at a speed that maintains it in the same position relative to the Earth. The stationary ground parabolic antennas are therefore always pointed directly at these satellites. Other smaller satellites orbit closer to the Earth at less than 2,000 kilometers. They are called low Earth orbit satellites, or LEOs. There are also MEOs, or medium Earth orbit satellites, located at 10,300 kilometers. At short distances like these, the Earth's pull is a great deal stronger. If the satellite is to maintain its orbit, the centrifugal force must also be stronger. So these satellites are made to orbit much faster than geostationary satellites. Then the two forces cancel one another out. So the ground antennas must be able to swivel so they can follow the satellite's paths. LEO satellites can be used to supplement various existing communications technologies. They are used, among other things, for paging systems, emergency road communications, remote surveillance of industrial or military installations, and electronic mail between portable computers. In all these cases, since the data is transmitted in packets, bidirectional communication is impossible. It's a little like the facsimile or fax machine. You cannot receive a message at the same time as you send one. The advantage of these satellites is the low cost of their send-receive terminals and their mobility. Thanks to communication satellites, it is now possible to communicate anywhere in the world, on the seas, and even in the air. Indeed, nowadays, you can even place a telephone call from an airplane. Some antennas can be transported from one place to another. Each antenna fits into a briefcase terminal. The whole unit weighs about 20 kilos. The hardest part is pointing the antenna in the right direction. Messages can be sent anywhere in the world by computer, fax, or telephone. Journalists use these tools when on assignment in foreign countries. Traveling salesmen use them to communicate with their head offices. Soon, using satellites, the small screen will be able to pick up hundreds and hundreds of TV channels. For the time being, however, large-scale interactivity between users via satellite is not a possibility. For that, we will need a different technology. Television hasn't ceased to amaze us. After color, stereo sound, and a profusion of channels, we are now witnessing the emergence of interactive television. Cable television is becoming more and more sophisticated. It no longer simply broadcasts television programs, but now provides access to databases and will eventually enable us to do our banking from home. Coaxial cable was born with television. The high-frequency Hertzian waves used for television transmission travel in a straight line. They are broadcast by antennas mounted on relay towers. As a result, Any high obstacle, such as a mountain or a high-rise, can block them. It is what accounts for the interference or scrambled image we sometimes get on our TV sets. Moreover, since Hertzian waves seldom exceed a distance of 200 kilometers, the coaxial cable, which is also used for television transmission, soon proved necessary in remote areas or rough terrain. Coaxial cable also increases the clarity of the signals and reduces interference. A coaxial cable consists of a solid conductor within another conductor, which is hollow. The space between the two conductors is filled with an insulator. These conductors have the same axis, hence the name coaxial. The central conductor transmits the signals, whereas the outer conductor ensures the grounding. In recent years, digital video terminals have been integrated to coaxial television sets. The terminal's built-in functions are operated by an electronic remote control, providing access to all the traditional and latest cable technologies. The user can choose the television mode, for instance, for regular TV programming or pay TV, or the telematic mode to access electronic mail services or to load software, including video games. To load a software program into her digital video terminal, the user simply requests it using her remote control. Since the content of the software is always circulating through the cable network, it is transmitted to the terminal as soon as it reaches the user's home. Users may keep the program in their digital video terminals as long as they want. Digital video terminals will also decode closed captions for the hearing impaired. Lastly, they also provide access to interactive television. In a sense, interactive television allows viewers to create their own television program. Sports shows lend themselves particularly well to this type of television. Indeed, the user can focus on a particular player, at the same time consulting that player's statistics, which are displayed on the screen. He can then go back to a general view of the game. This same technology will enable viewers to participate in game shows. In an interactive program, the viewer is given the choice of 3 or 4 answers. The way interactive television answers the viewer's choice is simply by switching channels. For example, in a quiz show, 4 answers are possible. When the viewer makes her choice, by pressing a button on her remote control, what she does in fact is change channels. 4 pre-recorded sequences are broadcast on 4 different channels. The explanation of the correct answer will, for instance, be broadcast on channel B, whereas channels A, C, and D will give the explanations relative to the incorrect answers. For the moment, cable television is unidirectional. That is, the user cannot send a message through the coaxial cable. But digital video terminals will soon be sufficiently advanced to make two-way communications a reality. At that time, cable users will have access to such services as teleshopping, remote administration, and basic banking, all of which they will be able to do right from their home. This type of technology will also have applications in home automation, in terms of computerized energy and security control, for example, or the reading of household electronic counters. Moreover, digital video compression will provide access to more cable television channels. Indeed, video images recorded in analog form can now be converted into digital data. That data can then be compressed in the following manner. Let's take the example of an image with a stationary background but mobile characters. Each movement of the characters is important and cannot be sacrificed. However, only one sequence of the background need be recorded. This type of digital compression, which eliminates the redundant data in a given image, is called spatial compression. Temporal compression, on the other hand, eliminates redundant data between two images. Compression greatly reduces the information to be transmitted, thus leaving more room for other channels. Video signal digitization will also enhance image resolution. With digital video terminals linked to cable networks, the cold fall evenings will seem a lot less boring. In telecommunications, the final frontier is teleportation. According to some physicists, it's conceivable. It would be done by transmitting, via known communication channels, the information required to reconstitute elsewhere, at some point in space, the copy of a particle. And if it can be done with one particle, why not billions?